Okay, so 9-3, circles in the coordinate plane. I do apologize for your graphs, but if you look on your paper instead of mine, you'll be able to read it as we go along. So, we have circles on the coordinate plane. We need to know what a circle is. Now, the technical definition of a circle is the infinite number of points equidistant from the center. So, this would be the center, correct? And would there be an infinite number of points out here?
Yeah.
Yes. Okay, and what would that distance be called?
Radius.
The radius. The radius of a circle, right? That is the distance from the center. But I'm not going to make you remember that definition. We're going to talk about the equation of a circle. And we're going to manipulate that today. So we have the equation of a circle at, you guys all know that this symbol's at, right? The origin. Okay, we got to remember what origin means. Anybody? What is the origin?
Original.
It's the start, it's the original, it's what?
It's the middle.
It's what coordinate? 0, 0. Okay, so an equation of a circle at the origin would be r squared equals x squared plus y squared. Is that familiar?
Pythagorean theorem.
Isn't that the Pythagorean theorem? Watch this. Look what I can draw right here. What did I draw?
A triangle.
A what kind of triangle?
Right.
Right. Where the R is the hypotenuse. Do you see that?
Mm-hmm.
Okay. I alluded to it, and I've been, since we've done the Pythagorean theorem, the Pythagorean theorem, the distance formula, and the equation of a circle are all the same thing. That doesn't quite look like the distance formula, does it? But what if I show you the equation of a circle not at the origin? And if we look at our picture over here, what's the center of the circle? What is it, though? What did they give you a point? What is it?
HK.
HK. So not at the origin is H and K. Okay? So that equation is r squared equals x minus h squared plus y minus k squared. What's that? Is that the distance formula? All I need to do is take the square root of both sides, wouldn't I? Except the distance formula has x1 and x2. This one has x and h. So when you hear h, you should think of what values? X's. When you hear k, you should think of y's. H is going to be your x movement, so that would be horizontal. And k is going to be your y movement, which would be what? Vertical. Now, Ainsley can contest to this. You seen H and K? Ainsley?
Yeah.
Yeah, a lot, haven't you? Any equation that I ever give you from this day till the end of the time that I have you, whether that be in geometry, algebra 2, pre-calculus, or calculus, will have an H and K. And the H will always move the function left or right. The K will always move the function up or down. Always. I promise you. linear, quadratic, cubic, square root, exponential, logarithmic, sine, cosine, tangent, when you graph those in trigonometry. Okay? By the time we're done, there's about 15 different graphs I make you manipulate. And guess what? Every single one of them are going to have in them an H and a K. And a starting point. Our starting point here is the origin. All circles start at the origin, and then you move them H units over, left or right, and K units up or down. Make sense? So H and K is the center of the circle. It's our starting point. It's our anchor. I always called it an anchor point. That's where it is. It was at 0, 0, and we're moving in H and K. Now, could I use this equation right here if I was talking about the origin also? Well, what would H and K be if it was at the origin?
0.
0 and 0, right? So if I plugged 0 in for H and 0 in for K, would it collapse all down to the original equation I gave you?
Yes.
Yes. So if there is one equation you need to remember, it is which one? That one. Because does that work even if it's at the origin? Yes. So you might want to do what with that equation? Highlight it. Put some big neon letters on it. Anybody got some LED strips, right? Put some LEDs or strips around it. Flashing light.
I need to go buy those too.
Yep,
Sorry
you need to
about-
buy those too. $5.
I don't agree with flashing lights.
Oh yeah, we don't want that. But okay, so that is what our day is centered around. You guys ready to start using it?
No.
Sure.
Thank you, Brian.
Brian.
Okay, so the next one says, what is the radius and the center of the circle? Well, if I just wanted the radius, well, 25 is the same as r squared, correct? So I have 20 r squared equals 25. But I just want r.
Square root.
So I have to take the square root. And I'm going to remind you of something that you have been taught, but you're going to look at me like you've never seen it before. When I take the even root of something, Ainsley, how many answers do I have?
2.
2.
Plus or minus.
I have positive or negative 5. Because if I took negative 5 times negative 5, I would get what?
Positive.
Positive 25. If I took positive 5 times positive 5, I'd get what? Positive. So either one of those gives me positive 25, right?
Mm-hmm.
Now, here's my question. Radius is the distance from the center. The word I used was distant. Yes, distance?
Mm-hmm.
Can distances be negative ever?
No.
No. So there are 2 answers, but which one is the good answer?
Positive.
A positive 5. I was going to write 15. So I just want to make sure you guys are aware, anytime I take an even root of something, it's a positive and negative. But in this case, only one of them is good. Make sense? Okay. So now it needs the center. So the center is H and what? K. So the center, well, what's the H?
2.
2. What's the K?
3.
3. Why don't you guys try the next one on your own? There's a couple tricks in there.
Why are they adding 5?
What's the equation? Is it addition?
I don't know.
On the equation of the circle, is it addition?
Yes.
No, on the original equation of the circle,
No.
is it addition? So how did subtraction turn to addition? Don't say it out loud.
Is it because
Don't say it out loud. Think about what makes subtraction turn to addition. You guys ready for me to start?
Probably, yeah. Because if I can't say it out loud, there's no need to play games with my mind.
Did you get r equals the square root of 13? Okay. It looks funny, but is the square root of 13 a number?
Yeah.
Yes. Okay. And the center is at 6, negative 5.
That's what I was going to say.
Who remembered to take care of that? Awesome, guys. So this says plus 5, and the original equation is minus, correct? How would you get a negative to become a positive? Another negative, a double negative. So when I look at these in the actual equation, they're always the opposite direction, aren't they? Because it's minus. So in this new center, it went right 6 and what? Down 5. And then they have a radius of the square root of 13. Make sense? Questions? Concerns? Okay. So now we tore apart an equation. Guess what we get to do now? We get to write the equation. You ready to write the equation?
Yes.
So the things we need to write the equation are r and what? We need the center, correct? And r. Once I have the center and r, can I write this equation? Yes. Okay, well the center should be pretty easy because the center is going to be my h comma my k, correct? So where's my center at? Look on your piece of paper, it'll be much easier to read.
0, 3. Or 3, 0.
3, 0? You guys get 3, 0? Okay, so h is what? 3 and k is 0.
Wait. So what does the other, point have to do with anything?
Nothing yet. That other point is what? 1, negative 2?
Yeah.
Okay, we're going to need that in a second. Because now I need my radius, don't I? Now, does this circle touch 0, 0? No, shoot. Because if it touched 0, 0, could I just count my radius? Yep. But now I got to find my radius, which is the distance from the center of the circle. How do I find the distance? The distance formula. So I need to use what 2 points? 3, 0, and what? 1, negative 2. So find your distance, like you've been doing the last 2 days.
Something went wrong. Please try again.
Yes, Siri can't do it for you. Well, she probably could. Oh, that is good. We could try it. Should I try it? If you said it right, she could do it.
Probably.
Did you get 2 square root of 2? Well, did you get the square root of 8? Getting pretty scared. Brian, did you get the square root of 8?
I got the square root of 8.
Which is 2 square root of 2, right? Brian? No? 3 minus 1 is what?
2.
Squared is
4.
4. Did you forget to square?
Yeah.
Okay, and 0 minus a negative 2 is plus 2, right?
Yeah.
Squared is,
4.
and 4 plus 4 is
8.
8.
1 minus 3.
Well, if you did 1 minus 3, it's negative 2, and negative 2 squared is 4. Doesn't matter which one you subtract. Because when we're squaring it, does the negative really mean anything? No. The big thing you need to be careful of is when you subtract a negative, you're adding it, right? If you're not doing that correctly, it is going to mess some things up. You'll see that today. Okay, so did everyone now get or understand how it is 2 square root of 2? So I have 2 square root of 2 as my r, and I have my h and k. Am I ready to write my equation? Okay, so the equation is, you guys are going to have to look at your paper. I can't keep going. R squared equals x minus h squared plus y minus k squared, correct?
Yeah.
So we have r, and we have to do what with it? Square it equals x minus h, which is, what's h? 3. Quantity what? Squared. Plus y minus 0. Quantity what? Squared. So remember when I square this over here, 2 squared is what? 4. And the square root of 2 squared is?
4.
Nope. The square root of 2 squared is 2. And so the whole thing is what? 8? Guys, we got the square root of 8. What's the square root of 8 squared? 8. So could you have come back to the square root of 8 and used it? Yeah, but I mean, it didn't tell you that. Haha. Okay, can I do anything with x minus 3? Nope. So it's just x minus 3 what? Squared. Don't forget your squared. You guys come up to me all the time and you're like, yeah, I know it's there. I'll put it back in on the end. What do you not do?
Put it back in.
Okay. Now it's y minus 0. So do I have to put a 0 there? Nope. So it's just plus y what? Squared. So that is my equation of my circle. Make sense? Okay. What am I going to do first on the next one?
Find your points.
Find which points?
The center.
The
and
center?
Radius.
I feel like this is really dark. Can you see it okay up there?
-1, -3.
Okay, so the center, Ainsley says -1, -3. You guys agree?
Oh,
Negative
-3,
three.
-1.
Thank you very much. I was waiting for somebody to say, no, lady. Okay, so what variable is -3?
8.
H. What variable is -1?
Okay.
K. Anytime you hear X, you should think H. Anytime you hear K, you should think Y. Mason. Good morning. Okay, R equals. How are you going to find R?
Distance formula.
Distance formula. So our 2 points, we have -3, -1. And what's your other point?
-4, -4.
Okay, so figure it out. Watch your negatives. There's your hint.
Sorry.
Is it dead?
It's at like 10%.
You're going to need it soon?
Oh, no, I'm not.
Okay, because I was going to say you could plug it into mine and it would go faster.
Thank you.
Just put it back here.
Okay. Thank you.
You're welcome. Because since that cycles, it's hard to... Yeah, there are lots.
think I got it.
Did you get the square root of 10?
Yeah.
Did you? After you wrote it down?
Yes.
After you copied mine, Brian?
Huh?
No.
No.
Did you get square root of 10 on your own?
Yeah. I did.
Thank you, Cooper, for being honest. Hey, if you did not get square root of 10, Do you need help figuring out why?
So do the points turn positive?
Well, because you're subtracting a negative, so it's -3 minus a -4, so that'd be plus.
It'll be 9.
So it'd be 1,
Oh, yeah.
and then 1 squared is 1,
Yeah.
and then -1 plus 4, which would be 3, squared is 9.
Okay.
Okay.
If you guys need to be writing that out, write it out. Correct?
Yeah.
You do not have to do this in your head. I'm just for time's sake. Okay, now I have R is the square root of 10, and I have H and K. What do I do? Plug it in.
That's where I get lost.
Plug it in.
I'm still on distance.
Plug it in. That's what.
Plug it in right here.
Great.
Just like this, Cooper. Try it.
Alright.
You should be in pencil. Are you in pencil?
Yeah.
Okay.
Oh.
No, I'm not.
There's pencils back there. You should even take notes in pencils because math stands for mistakes allow thinking to happen.
I don't think that's what it stands for.
I don't care what pencil you use.
It was a pen mistake.
Oh,
I mean, math means fun.
do your assignment.
What? What do you want?
Okay, shush, please.
Nation for falling asleep in class.
There we go. Good W.
Now that you're finally done, I'm done.
There. What, Mason?
Hey, shush.
Aren't the second ones wide? Yeah.
Oh, yes. Yeah, that's besides the point, right? Yes, they are wise. Guess I'll know who just copied my mistake, right?
I put Y.
Okay, so I get 10 equals x plus 3 squared plus y plus 1 squared. That was a weird one. Why are they pluses and not minus?
They were
Double
negative.
negatives.
Double negatives. They were negative before. It's the only time the two wrongs make a right every time, right?
See? I told you 2 wrongs make it right.
No, only in math. Only with positive, negative numbers.
Sometimes.
Okay, questions before we go on? Okay, because now we're going to do something else.
Yay.
So now they just give me some words and they're going to ask me if something falls on the circle. So it says circle Q. So typically what we do is I'm going to come back here. If I were to name this circle Q, I just have a Q by the center. Okay? That's how they name them. So a circle Q has a radius of 7 and a center at the origin. Does the point -3 square root of 2, comma 5 lie on circle Q? So what was the equation of the circle again? R squared equals
H minus, or X minus H.
x minus h
Squared.
squared plus
Y minus K squared.
y minus k squared. So if this point right here lies on this circle, this equation would be true, correct? So all we do is plug everything in, and if the left equals the right, guess what?
That's right.
It's on the circle. So we need to go through and find our R, our X, our H, our K, and our Y. Well, R. What's R?
7.
7, right here. R, right? Where do I get X and Y from?
Parentheses.
Does the point.
The point. Does the point. So this is my X and this is my Y. So -3 square root of 2 is my X and 5 is my Y. Where do I get my H and K from? What is H and K?
X and Y.
Nope.
0.
But what is it? What part of the circle is it?
Origin.
The what? It's the center, right? And it is at the origin. So what is my H and my K? 0 and 0. So H and K. So I have R, H, K, X, Y. All I do is what? Plug it in. So we have 7 squared equals, what's X? Negative 3 square root of 2 minus 0, parentheses squared, plus Y, 5, minus 0 squared. Where did I get all those numbers?
From X, Y, and HK.
X, Y, H, K, and R. They were there, right? So if I subtract 0, that doesn't do anything, correct? Okay, so 7 squared is 49. Remember, when I square that negative 3, I have to square negative 3 and square the square root of 2, yes? So negative 3 squared is 9 times 2 plus 25. So 9 times 2 is 18 plus 25. So what is 18 plus 25? The left-hand side, you just keep bringing down that 49 because we didn't change it. 43. You guys agree with Ainsley? Okay, does 49 equal 43? No. Put a not equal, cross it out, and is the point on the circle? No. So,
Nopers.
negative 3 square root of 2 comma 5 does not lie on circle Q. Looks like an eyeball, doesn't it? So the next two examples are exactly that, guys. We'll do one more together and you do one more alone, or do you want to do both on your own? One more together. Okay, everyone ready to go on to the next one? Okay, so remember, I'm going to have to move mine up, so you're still looking at this equation, correct? Okay, so we're going to, it says determine whether each point lies on the circle. So better make the equation true. So I need an H, a K, an X, a Y, all that, right? So I'm just going to do this one a little bit differently. I'm just going to write down R. What's R?
2 square root of 5.
Okay, so 2 square root of 5. I need H, comma, K. So what's that? 0, 0. See, I'm just writing it a little bit different this time. And then I need an X, comma, Y. So negative 3 square root of 11. And then I just do what with those? Plug them in. So somebody want to help me out?
2 square root of 5 squared.
Okay, the whole thing squared. Make sure you put parentheses, because if you don't put parentheses, you're only squaring the square root of 5. And we're squaring everything, right? Equals.
Negative 3 minus 0 squared.
So negative 3 minus 0 squared plus square root of 11
Minus 0
squared. Okay, so the zeros don't do anything, right? So square both. So 2 squared is
4.
4. Square root of 5 squared is?
5.
So I get 20. So the right better equal 20 if this is on the circle, right? Okay. So negative 3. Ooh, I wrote a 0 up here. Nobody caught me.
Then you wrote a 0.
Thanks. Okay, negative 3 squared? 9. Last period I squared it twice. That didn't work out. Okay, square root of 11 squared? 11. So 20 equals what? 20. So what's that mean?
You have good vision.
So negative 3 square root of 11, what? Does lie, did they give me a circle? Nope. On the circle. They didn't name the circle, did they? Okay. Well, this one has less words, but let's see if you can figure it out. So you try this one on your own.
Wait,
What?
I thought the radius was the middle, the center.
No, radius is the distance from the center. Can I start now? You guys far enough along? Yeah, no, just don't pay attention to me, right? I know I'm weird. Don't have to tell me.
I don't think I got this right, but we'll see.
Oh.
Is that your XY or your HK?
I did it again. I put 0 up there.
Dang.
You like zeros today.
Evidently.
X, Y, H, K.
Is that right so far? Let's go.
Hey, did you get lying on the circle or not? No, because 27 does not mean. Guys, when you show me your work on your paper, is there any less work you could show?
No.
No. I mean, I guess maybe you don't need this part right here. But you can't just tell me yes or no, can you? You have to prove to me yes or no. How did it go? Pretty good? Cooper, did you get it right?
Yes, I did.
Any questions before I send you to go work on your assignment? Okay.